Right, you're 12. I just need you guys to get your calculators as well to be ready to do some calculations. Right, we're going to go back to the day where you went to the primary school and you collected data. And remember, we had you collected a lot of data. If I can show it quickly, it was over here. Um, that wasn't used. I don't think we took a map. Oh, there we go. We did. All right, and you went and you collected all of these P hats. And altogether, we had 32 samples, or 32 sample proportions that we collected. And then I got a few boys to the front to remember to total all of this and add up all the totals and get that percentage for us. And I just remember you guys couldn't agree on the value there. So, and I can't remember either, but I'll just sort of make it up. So let's just say we took all of the students, right, and we put them in the hall, and I'll just make it up. So 423 that we had, and we found that 47 of them had blue eyes. So let's work that out quickly. My pen's not working now. All right, so we'll try again. So let's just say that there were 523 students and 47 of them said they had blue eyes. That works out to be just about 9% of the population in the primary school that will have blue eyes. All right, so again, I'm just going to read, please stay with me. It says, what do we think the actual proportion of blue-eyed students is? All right. While the sample proportion P hat will provide us with the best estimate of the population proportion P, it is unlikely that the sample value will be exactly equal to the parameter being estimated. Hence, a sample point estimate is most useful if it's combined with some information about its precision, indicated by an interval estimate called a confidence interval. When working out a confidence interval, we must first decide on a degree or level of confidence. We want to be very confident, so it makes sense to have a high confidence level. In most applications, they choose a confidence level of 95%, and this is a very strong tradition. So just remember, in practice, we typically do not have a long run of repeated samples at all. We have a single sample size of n, and we calculate the p hat, and we calculate a single confidence interval to characterize the precision in the result. Any actual interval either contains or does not contain the true value of the parameter p, although we don't know whether it does or not because we don't know the value of p. The larger the sample that is used, the narrower the confidence interval, and the more likely it is that the estimate will be close to the true population value. So what we're going to do now is, and I've already done it, so I'll talk you through it, and then I need you to write this down, please. We are going to construct a 95% confidence interval based on our sample proportion P hat. So you will go to the formula sheet, and this is the formula. Just on the right-hand side, this is how we calculated the sample proportion. We had 47 students who had blue eyes out of a total of 523 students. And you can see I just substitute. Now take your time and substitute the values into this expression over here, and then see if you agree with the two answers that I got. So just pause the video now and do that. And you can now see that the lower value of our confidence interval is around about 0.065, and the upper value of our confidence interval is 0.11. So based on our P hat, we have built this confidence interval, and we are 95% confidence interval that the population proportion does lie between this upper and lower value. All right, and expressing that as a percentage, we can say it lies between 6.5% and 11%. So, and we do remember, because we Googled it a little bit, the population proportion of blue-eyed people is 9%. So we've done a pretty good job with our sample proportion over here. And the reason why we got a pretty good indication of it is because our sample size was large. Remember, a sample size is considered valid and appropriate if it's greater than 30. So 523 is pretty good. Okay, so we're now just going to move to our graphics calculator. So here we sort of built it. We did use a calculator to, do all our number calculations. But from scratch, we went to our confidence interval. We did all the substitutions, and we got our confidence interval. On the calculator, it's obviously a lot easier. So please make sure you have your calculator next to you. Let's have a look at this example. A survey found that 237 out of 500 undergrads university students questioned intended to take a postgrad course in the future. Find a 95% confidence interval for the proportion of undergrads intending to take a postgrad course. So based on the sample size of 500, build a 95% confidence interval. All right, so what you do is, and you can just read through it as well. So you go to stats, as we always do. At the bottom now, you'll see, if you look at F4, it says INTR. So that stands for interval. So press that, and you're going to press the Z-score. We've got one proportion, so 1. And our confidence level is 0.95. Our X will be the number of people in this, not the number of people, the number of people with that specific characteristic. So the people who will do a postgrad course was 273. The populations, the sample size was 500. And if you just execute that, you get your lower and your upper values of the confidence interval. Okay, so it's pretty easy on the calculator, as you can see. Let's have a look at some more examples. All right, so we're going to do these on our calculator as well. And the only difference between these two examples is the sample size. So we're going to see how the sample size changes the confidence interval. So we're going to be working with 20 children, and then we're going to increase the sample size to 200 children. So following this example that we did over here, I want you now to do the same on your calculator and find the confidence interval for me. So pause the video and find it. So using your graphics calculator, you get these two confidence intervals. You see, for the X, you had to remember that little formula P hat is equal to X over N. So X will be P hat times N. So that's what I did to find the X in both cases. And have a good look at these two confidence interval that you get. So you can see that the bigger the sample, the narrower the confidence interval is, and the more likely it is that the estimate will be close to the true population value. All right, on the next video, we'll look at margin of error.